Point-slope form is similar to slope-intercept form in the way that you can pull out your slope and your intercept when looking at slope-intercept form. You can pull out a point and a slope when looking at point-slope form. M is once again representing your slope of your line in slope in your point-slope form. And for point-slope form, you can pull out your point with your x and your y. In our slope formula, you have x1, y1. In your point-slope form, our book uses x0, y0. And that's kind of because it's referring to there's only one point, and so it doesn't use 1 and 2. It just uses 0. But it's really the same as saying x1, y1. I tend to say x1, y1 just because that was how I was taught, and that's what I'm used to doing. So I tend to write x1, y1. What number you use really doesn't matter, just like with the slope formula. And you can actually, with point slope form, our book offers both of these versions of it. This one here on the left is the one I use most often, and that's the one that I've seen used most commonly. But our book offers both of these, and they're both derived from the slope formula. The slope formula is slope equals y2 minus y1 over x2 minus x1. And if we were to multiply both sides by the denominator, it would cancel out the denominator on the right side over here, leaving you essentially with this over here on the right, where you have your your y values for 1 point on one side of the equation, and then your x values for, I said 1 point, but I mean 2 points, your x values for 2 points on the other side next to your slope. And then to get this form of it, you would take one of your y's and move it to the other side. And that would be just, adding it to this side, which, gets you this equation here. So they're all equivalent, which is why it offers you both of these. Well, we can look directly at this equation and this equation and pull out our slope. That is the number sitting in front of our parentheses. And then we can pull out a point. That is our x, which is inside the parentheses, and then our y, which is outside the parentheses. Now, make sure you pay attention to the signs in front of the numbers. The equation has a minus inside the parentheses and a plus outside. If there's anything different than that in your equation, that means that the value of your point is different and is changing that to the opposite. For example, when we look at this 4, in the equation, it should be a minus, but we have a plus. In order to turn this minus into a plus, that means our point for our x value must have been a -4, because a minus a -4 is the only way to get that plus. And while we're at it, the 7 is our y. And this 3, the negative 3, is our m. One thing about the point slope form is that even though it's given to you, even if your equation is given to you in point slope form, if you prefer slope intercept form, it's not that difficult to apply a little bit of simplification and change that into slope intercept form by doing a little bit of distributive property and then simplifying to get slope intercept form. So distribute that number on the outside and then combine like terms. And voila, you have slope intercept form. So you can keep it as point slope form. Some situations it's nice to have that point and that slope. And in other situations, it's nice to have your slope and your y-intercept. So it's interchangeable. You can go from one way to the other and then back again. So I wanted to point that out. And the other thing I want to point out in this video is, how do I create an equation that if I'm given some information, I can create an equation that is written in point slope form and then convert it into slope intercept form. So I've got some steps here, and you can actually do step 1, step 2, step 3, kind of like we did for slope intercept. I just did step 1 and 2, but step 3 could be to do a points, but usually you're given the points. So step 1 is to determine your slope using your equation. And then step 2, we need a point. So find your point. Usually that's given to you. And then you want to substitute that point and your slope into your equation. I'm going to go ahead and rewrite my equation over here so that it is visible when I need it. And as I mentioned, you can put a 0 or you can put a 1. It's up to you. I like to keep that 1 so it's consistent with my slope formula here. That way, when I number my point, I can use the same point I use for 1.1 here as my 0.1 here. They actually gave me the slope in my problem here. It says a line slope is 47. The line passes through the point -4, -2. Find an equation of this line in both point slope and slope intercept form. So since I know my slope is 47. Step 1 is done for me. So then I just need to move on to step 2, which is taking my information that is given. My slope is 47, and I have my points here. I'm not going to rewrite that because it's already kind of written up there. X1 is going to be -14, and Y1 is going to be -12. So I just kind of plug that into my equation, and I've already written the equation over here for us. So M is 47, X1 is -14, and Y1 is -12. We're going to go ahead and simplify that to get Y equals 47, X plus 14 minus 12. And it does say point slope and slope intercept. So we're going to go ahead and do some simplifying to turn that into y-intercept. So we're going to distribute that 47. 47 times 14 is 658 And then I will subtract 12. It's a really large number. I wonder what that number is supposed to be for, huh? 646. And those are my two equivalent equations. We have our point slope and our slope intercept.